What is algebra? You guys know I have a bit of an obsession with names. Okay, I'm gonna go through this part by myself. Algebra. It comes from an Arabic word, algebra, right? Algebra. Which means it means the reunion of broken parts. I'll say that again. This Arabic word, it's an Arabic word that means the reunion of broken parts. In fact, in some languages in the world today, like Spanish, this same phrase has come over to those languages as well, and it's the phrase used for setting bones after they are broken, right? They need to be reunited and put together. They're broken, but we can recombine them. Now, as maths goes, right? Algebra is often experienced with a lot of difficulty, and there's a good reason for that, okay? Algebra, well, compared to you guys, is very, very old. It's very old. It's been around for hundreds of years. In fact, it's been around for about 500 years, okay? But when you think about it, on the mathematical scene, algebra is super, super new, right? A lot of the maths that we've been learning is thousands of years old because people have discovered it a long time ago, right? Pythagoras' theorem, for instance, right? We've learned that, and civilizations have known about that for millennia, right? But algebra is new, comparatively. It's only been hanging around for a few centuries. Now, not just in terms of like society, right? But think about like the human race. If this has only been around for this amount of time, human brains haven't evolved to understand what algebra is. It's new. It's an invention, right? So it should make sense that we experience a little bit of difficulty when we get to this, right? I have young children, and one of the first things that you do, if any of you have younger siblings, is you learn to count. Counting, we have been doing since forever, right? Tens of thousands of years. We're very good at counting. Your brains are built for counting. Your brains are not built for this. This is not easy, right? So we should expect a bit of a challenge. But even though our brains aren't built for this, right? Perhaps in fact, because they're not built for this, that's what makes this so powerful. In fact, in the 1500s, and you can write this down next to where your title is, right? In the 1500s, algebra was what we call a game changer. It's a little bit like when someone invented gunpowder, right? Or the bow and arrow. And it changed warfare forever, right? Algebra changed not just maths, but problem solving and the way that situations are approached and analyzed. It changed all of those forever. Here's the key idea, right? Yesterday I had a family lunch, okay? And for lunch, I went to Costco and I bought some pizzas for lunch, okay? Bought some pizzas for lunch. They're ridiculous things. They're so big you can't fit them in a standard size oven. Okay, I had to slice it into pieces and pop it in to warm it up. They're enormous things. I could barely fit it in my car. I bought two because I'm a big family. And they're all sliced into, actually this is wrong, they're sliced into 6 slices. And these are enormous pizzas, right? So when they're only 6 slices, each slice is literally like the size of a plate, okay? So it's like, okay, here's your 1 slice. Okay, now here's what we did. I told you I had 2 pizzas, so I had 12 slices of pizza, 12 slices, and then I wanted to know, well, how many slices of pizza can each person have? And there were 6 adults there, so I was like 12 divided by 6. Okay, everyone could have 2 pieces. Easy. Okay, 12 divided by 6 equals 2. Okay, now these are what maths problems were like for centuries, right? They're problems where you know what everything is equal to, and you have a problem, and you can work with those numbers and you can come up with an answer. Okay. Algebra is a game changer because it's where people realize, wait a second, you can have a problem where you don't know what the numbers are. Where you can like, I don't know how many pieces of pizza, maybe I want to know how many pieces of pizza I should buy, right? And I know that I'm going to have to divide it by 6, and then I want, say I want, 5 slices for everyone because it's going to be some very hungry people or something like that, right? It's this idea that you cannot know what the numbers are. Like maybe I don't know how many pizzas there are, and maybe I don't even know how many slices they're going to be sliced into. But if I want something, I can still work with these numbers even though I don't know what they're equal to. That's the game-changing idea behind algebra, okay? Which is why in algebra, and this is a little subheading you can make, the key idea is that of starts with a V. Does anyone remember what the word is in algebra? They're called variables. Variables. Okay, so write that down as a subheading. Question.
Why do we have algebra if it just makes it a bit harder?
Okay.
Does it help?
Yeah, sure. So let me come to this idea. Why do we have algebra if it's so hard? Okay. Maybe this is a good opportunity for me to explain. Algebra is a bit weird in that it's an Arabic word. The reason why is if you think about all of the other words you know and how we learn things, right? Think of all the words like attached to subjects, like geography or mathematics, or even within mathematics, like geometry and trigonometry and all that kind of thing. All these words, they all come from Latin. Now, maybe you're like, yeah, so? Like lots of things come from Latin. That makes sense because as like society, Western society was growing up, all the people who were like scholars and people who went to school and learned, they all learned in Latin. So it makes sense that all of our learning words and school words come from Latin, okay? But this guy comes from another language entirely, right? It's because for centuries we weren't doing maths like this, but we saw that these guys were, and like the Gamechanger does, it doesn't necessarily make things harder. It opens up a whole bunch of harder problems that you couldn't touch at all unless you knew this, right? So the reason why algebra is harder is because it's a little bit like, well, it's a little bit like the way driving is harder than walking. It's like, why do I have to learn driving? Well, because you can go all these different places if you can drive, but you can't go if you can walk. And in the same way, flying a plane is harder than driving a car because flying a plane can take you all these different places that driving a car can't. Does that answer your question? Okay, so the heading you made was variables, and next to that you can put another name for the same thing, which is pronumerals. You might remember that. Pronumerals. So this whole idea of algebra is solving problems where you don't know what the numbers are, right? But you can see it can start to get tiresome if every time you don't know what a number is, you write a question mark, right? We've got different numbers that we don't know what they are, so I need to be able to distinguish between them. And that's what pronumerals and variables are about, okay? So for example, you know, the most common variable is x. Very good.
Why?
Now, I'll tell you another story another time about why it's x. Okay? But it's why we have things, you know, it basically means unknown. Like it's something, but I don't know what it is. Which is why, by the way, just as a side note, it's why x-rays are called x-rays. Because when they were discovered, they were a kind of radiation, and they were like, I don't know, it's a kind of radiation, but we don't know anything about it. It's not visible, it's not infrared, it's not UV, it's something else, unknown. So they called them x-rays, and then the name just kind of stuck, even after we found out what they really are.
What are they?
Okay, you can go to your science class and ask for that. Okay, so simple idea, right? If we say x is some kind of number, right? We call it a variable because, well, it can change, right? Just like the number of pizzas you buy, it can change, it can vary, so it's variable, right? We use the pronumeral x to stand for that, okay? So we could write, for instance, x divided by 4 equals 4, right? So there's some number in this case, right? That if I stick it in here, it'll equal 4, and that's called solving this equation. What is the number you divide by 4? You get 4. It's 16, very good. Brandon.
For x, you wrote it different way x.
Oh yeah, sure. Okay, that's a good thing to mention. So there's lots of ways to write x. Like you might write an x like this. I'm going to encourage you, even though I did it there. I'm going to discourage you from writing x like that. And the reason why is because that looks exactly the same as a multiplication sign, right?
Times.
So that's exactly right. So I think this is not that good. I mean, if you have a look down there, right, you can see it's kind of unambiguous what I mean here, which is why I can kind of get away with it. But when we write equations and expressions and so on, it's probably better not to write it like this. Here are my suggestions. You could write it like this. That's kind of like a C and a backward C next to each other. Or alternatively, you can write it with like a kind of wiggly, like a multiplication sign, or one of the signs has like kind of tails next to it.
Approximate x.
Kinda. So I think these are better. You'll be able to tell them apart. Okay? So, if you remember, there's a bit of shorthand you can use. For example, instead of saying 5 times x, we tend to write that just as 5x, right? So rather than saying, for example, you know, five boxes of pizza, you can just say 5 pizzas, right? It's the same kind of contraction, just making things faster.
So the answer of it is basically just take out the equation.
Yeah, that's right. It's not that hard, okay? Now you can combine all kinds of other operations, and order of operations is still the same. So for example, if I showed you this, 5x minus 4, right? Which operation would you do first? Think about it carefully. Yeah, Tendai.
Would you want to find out what x is, so you do the minus first?
Okay, well, if I knew what this number was, right? When, say, x is equal to 2, might be equal to something else, because it's variable, but let's say that, right? Well, okay, so remember that 5x is short for 5 times x, right? It's not 5 and a number, like they're digits, okay? There's multiplication happening in there. So therefore, this really is 5 equals 5 times 2 minus 4. So now you can see which operation you should do first, right? You should do the multiplication. 10 minus 4, so that's 6. Okay, does that make sense?
Yeah.